Hi, Dr. Campbell. My name is Greg Sully. I'd just like to talk to you very briefly about this basically darkening skies project by the UK government. Some context which you might not be aware of, and I think is important now. I am writing a letter to you as well with a much more detail, but I thought it's better put this out here, tag you in it so you actually have the information today rather than Tuesday, Wednesday next week. I do also apologise. I have a condition, dyslexia. I have a condition called fibromyalgia, so I'm always in pain, and it causes me problems on recall, which is not great. I think I'm over COVID. Just had a nice bout of horse dewormer, which I finished last week, and I got some of that fancy NAC you recommended coming in the next week or so to see if I can get the remainder of side effects with long COVID got rid of. Anyway, I didn't have a vaccine. I contracted COVID back in October 2019. I've had it on and off for that time, with the exception of about 6 months from November 3rd or 4th to like mid-June 2021, so November 2020 to mid-June 2021, as I found by accident, but CBD oil helped alleviate my symptoms as an untested theory. That theory turned out to be quite correct, as I'd contacted Lethbridge University, Jerusalem University, as well as a multitude of other universities, research institutes and so on, saying, hey look, this is totally improving, don't know if it's true, it could be any other reasons, but I found by taking CBD oil, which is the over-the-counter legal CBD oil, I found that the COVID symptoms I had reduced. Now, we didn't know 100% this is COVID. I'd had an antibody test which came back, I think it's 1,200 count or something in that region. Later on in 2022, I had another test which the British government recommended you must have because you're high risk. This way we can test if you've got antibodies, do the jab. The day I sent the box off, I got results telling me, oh yeah, you had no antibodies. That's suspicious enough when somebody tells you literally just posted it and we got results in. I don't think we have magic boxes at the post office. But then a week or so later, oh yeah, you have no antibodies. So I call bullshit on something like that when somebody tells me that's a scientific fact, and then I find out later that the researchers didn't have comparative samples. I'm not trusting when somebody tells me something which I know sounds like bullshit. As a climate scientist, I want to find the truth. I hate it sometimes where I will find something which I've believed for a long time to be true and then find out it's bullshit. And yeah, it annoys me. But at the end of the day, my goal is to find the truth. And if that's the truth, then I accept it. There's no point in me arguing and debating. That's the truth. Now, regarding the cloud dimming, I did some research last week and this week into what's going on, what's happening. I keep calling it Solar Dawn, and I don't think it's Solar Dawn. I can't remember what the program is. I will have a look and see if I can find it and attach it to the email I'm sending you. But I was doing a deep dive into the Solar Radiation Modification Act in the United States. Now, this was a program put in place by Joseph Biden's White House in 2023. Excuse me. Pardon me. Oh, sorry. Complications I've had from long COVID. What was it? So we have the President Biden Solar Radiation Modification Act, which came out in 2023 following the terrible choice of switching from leaded aviation fuel to unleaded aviation fuel, which caused a sudden peak in the global warming statistics. So if you look at charts for global warming, you will notice there's a slight rise in 2020. This is because aviation traffic just dropped out, so the fuel which is used in aviation at the time, which was leaded fuel, causes an effect called global cooling. Global cooling is where the sulphur dioxide, where the sulphur in the fuel itself, which is derived from sour crude oil. So sour crude oil is very, very rich in sulphur. So the problem is, what do you do to get rid of that sulphur? Back in the 1800s, when we had the original, I get them too mixed up. I think it's John L, but it might be John M. Rockefeller, or it might be another middle name. I don't know. I can't care. Not relevant right now. The original John Rockefeller's solution was to address what was back then called skunk oil, which was to add lead in a molten state, which is 320 degrees Celsius, I believe. So in that molten state, you pump it into a refinery process where I salivate a lot, and I don't know why. Again, side effects from long COVID or something else. I don't know. So they would put molten lead in with the sulphur in the refining process, and the sulphur would bind to the lead, prevent the sulphur from causing a knocking effect in the engine. The term is called knocking, basically where you're having misfiring or premature ignition of a fuel, or in what's it called? And this is important. Irregular burn patterns in the combustion process. So this is where the engine's just not running properly. The burn profile's wrong. The engine's not playing. It's knocking around. Which adds to wear and tear of the engine itself. But you'd also need to decarbonise the engine more frequently, because the carbon would then bond to the sulphur, to the carbon, to sulphur. Literally like we have fatbergs today, which you have an unflushable wet wipe down the toilet. You'd have a fat which is in the stool, which would then bind to the actual wet towel. So what would happen down the pipe? We're getting limescale deposits. The wet wipe would catch, then the grease would run across it, then another wet wipe, grease, and eventually clog it up, and we end up with fatbergs. Same in the pistons of the engine, you'd have carbon deposits, then sulphur, carbon, sulphur, carbon, sulphur. We still have this, but it's greatly reduced. You'll probably see in a car doing 100,000 miles, like a little yellow cake, not uranium, little cake deposit of the sulphur and carbon, which then you need to clean out to make it run properly, more efficiently. With a regular service. I studied in aerospace engineering. When I was younger, I had to rebuild a jet turbine engine after the teacher just sort of left. He couldn't be bothered, since I was the only person left in the class. Everyone else had jobs, I didn't. So it's like, I give up, I'll walk off. So I had to learn how to basically fix and maintain an engine. And so yeah, I don't see a point of exaggerating. This is stuff I've learned. This is what I've learned as qualifications. I hold an aerospace engineering qualification. I don't hold a formal climate science degree or qualification, as I've been screwed over in the past from companies like Viridor and Brighton University refusing to let me pass and qualify because they needed me to sign gag orders. I disagree with that. When somebody tells me I have to sign a gag order in order to get a qualification so I can't practice because they want to perpetuate lies, I'm not doing that. I'm not bending that to that degree. I think that's disgraceful. Anyway, so I've got quite off track. So basically, what was happening is you'd put the lead with the sulphur, and that would prevent the sulphur reacting in the engine. You'd when it's combusted in the combustion chamber, the lead melts off, the sulphur reacts with the carbon dioxide, which is being combusted at that point in time. So imagine inside the piston you've got a high pressure environment, lots of heat, the carbon has already ignited from the fuel, so the hydrocarbon is now turning into carbon dioxide, the oxygen's burning, causing carbon dioxide. The sulphur is now separated from the lead and it's now reacting with carbon dioxide. So it takes an atom of oxygen from 2 carbon dioxide molecules to form sulphur dioxide and carbon monoxide, and that's where we get the sulphur dioxide from. Now, one of the key problems with one of the key problems with sulphur dioxide is it causes acid rain. It reacts with nitric acid, nitrogen dioxide, and sulphur dioxide, forms a nasty form of acid rain. Now, you can get different versions of it, but the more common one is a mixture of nitrogen dioxide and sulphuric acid, along with nitrous oxide, which can also form with sulphur dioxide to create an acid rain effect. Now, we've seen that greatly reduced because we switched more from widespread coal use down to a lower use of coal, and even with what President Trump has pushed in the United States, which is a green coal technology, it's producing less junk in that process. It's not something like the old school green coal, which would produce an excess of nitrous oxide and methane in its process, something I uncovered back in the 2000s. I contacted my local MP, contacted the Labour Party, shared them the public information, and through doing deep research found all the problems with the green coal system which was being proposed at the time, and persuaded them to give me a copy of their full report, because clearly they lied in the details, and when I got told, oh, whatever you do, don't give it to government. So I gave it to the Labour government, because when somebody's going out their way to make something that sounds really great, when they lie, they need to be uncovered. The truth needs to come out, and you need to understand it. So that's what. So the sulphur dioxide would be forming. That would be creating a mirror-like sunglass effect, reflects away some of the sunlight and some of the heat. So the effects of global warming were reduced. So we didn't see massive rises, but we did see rises. Now, there's a video I will link in the email, which is a BBC Horizon video on global dimming. I'm assuming you haven't heard of this, but if you have, you know the effect I'm talking about. This was discovered following the attacks of 9/11, where the air corridors around the United States closed down, and what they found was there was a reduction in the particulate in the atmosphere, and temperatures rose up. Now, the reason the temperatures rose up actually was because it returned to the normal state rather than it got hotter. There's common conspiracy theory pushed by the likes of the Club of Rome, by the People's Republic of China, by lots of persons who are very supportive of agendas pushed by the Club of Rome, the World Economic Forum, which are one and the same. They're founded by the same people. It's founded by the Rockefeller brothers, William Gates the first, and other key players. Founded the World Economic Forum with Karl Schwab in 1971 on the back of the Club of Rome, and the two entities work hand in hand. And I would say, if you in any doubt, if you want to know the agenda, what's going on, have a look at the World Economic Forum's C40 cities, which Sadiq Khan is the current chair of. I don't trust him for that reason. It's like persons who are so committed to, I know everything about the environment, I'm an expert in this, and then support notions we need to reduce the population of the planet because that's a scientific fact. I don't trust you. I don't trust those persons, because they're not relying on science, they're relying on politics. And I've had 30 years of understanding the problem with climate change, and quite frankly, a lot of common sense is needed to solve a problem, as it's an excess amount of carbon in the environment. We can plant crops, cannabis and hemp plants are the highest absorbing, highest carbon retaining plant for their size. So you can put trillions of cannabis and hemp plants on 6,124 square miles of land, and that's equivalent to 1 trillion trees worth of carbon change. Not just young trees, we're talking mature trees. So the cannabis and hemp plant matures within about 4 months, and that's retaining the most amount of carbon from the environment, whereas a tree takes between 7 and 20 years to mature. So you're getting the highest amount of carbon out of the atmosphere. So it's a lot of it's common sense. The other problem is we have a lot of assertion of we got to lower the carbon dioxide. Carbon dioxide is a problem. Oh, we have solutions but can't get rid of carbon dioxide. Again, that's bullshit. Carbon dioxide we can get out a few different ways. We can use electrolysis in a vacuum to remove it. We have platinum and something else. I can't remember the other element off the top of my head. Put this in a vacuum and we can extract the hydrogen from the carbon. So we basically end up with purified carbon and hydrogen, which can then be reused either to bind with the carbon dioxide from systems like anaerobic digesters using the Saber bash process, which is currently used to make ammonia, but the Haber bash process, we're basically using heat and pressure with carbon dioxide and methane to form water, carbon dioxide and hydrogen to form methane and water. So again, you now have methane again, which you can then use electrolysis to split the comfort. I left that bit out, actually should have. So you would use anaerobic digesters to break down methane, because methane's a lot easier to break the bonds of the carbon than it is to do in water. Water is something like 300 and something odd joules of energy, whereas it's maybe 400 joules of energy, whereas the methane is something like 280 to 300 joules of energy, so a lot less than, I think it's 380, which is the carbon dioxide. I'm not going to say that for sure because I don't have the notes to hand and I'm probably wrong. I will have to go searching for that information. But if you want to extract hydrogen, your most efficient product is to use methane rather than water, because it's less energy intensive and you get an extra bit of hydrogen for your effort, whereas with water you get 2 hydrogen, with methane you get 4 hydrogen, so you're making more hydrogen for your buck, and the bonds on the carbon and the oxygen are not much of a difference. But again, it's a little bit easier because the bond is not so tight, so you can break the carbon away relatively easily. But the normal process, I'm sorry, I'm going to, you don't need to know this. Basically, a lot of it's common sense. Now, since 2022, we switched to using unleaded fuel for aviation. Now, unleaded fuel for aviation contains cobalt instead of lead. There is a problem with that. Now, this problem dates back to the 1930s when we started introducing unleaded fuel which contained cobalt. By the 1940s, in World War II, we have really high rise in people developing asthma, as the fuel was being used for agriculture, including in blowtorches, in garden heaters, to basically get rid of insects and creepy crawlies as an insecticide, because it was cheap and it was inexpensive, it was cheap, and it was recognised as a insecticide during the war effort. Because if you have to manufacture your insecticides, then ship them over, it becomes an extra complexity, especially when we've got chemicals like Cyclone B, which prior to what the Nazis, BASF, developed an odourless version of it. Prior to that, that insecticide would be highly effective, but they needed better solutions because it's a complex process to make Cyclone B. It's also a complex process to make a lot of the fertilisers, so you need more and more fuel resources to do that. Whereas you have unleaded fuel and you know it's an insecticide, why not? It's convenient and easy to use. So that's what was being used. And when I researched this back in 1997, 1998 to figure out what the hell this thing in unleaded fuel was, because it was being used under the code names of backstraw and blackstraw, I didn't know what it was. I couldn't get from Freedom of Information requests what that backstraw and blackstraw was. And when I did searches through the National Archives and war records and basically try and figure out what the hell this thing is, because learning about the fossil fuel industry is one great thing to do, so you understand what the problems are to basically developing green technology. I understand the problem from 30 years of learning and understanding it, that is scalability. We don't have scalable solutions. The best scalable solutions we have are solar panels and wind turbines. The problem is we ditched the good systems, which are like the Iranian wind turbines, in favour of the fossil fuel industry mandated wind turbines, which aren't really that good. And we ditched American-made solar panels and British solar panels in favour of Chinese ones, which are pretty crap. Yeah, they have better performing, but they're weak, they break down, they use a lot of toxic materials. I would buy American, I'd buy French, I'd buy British, I wouldn't buy Chinese because it's pretty crap. So we have a problem of scalability. We don't have scalable solutions for tackling global warming and climate change. Soon we will, as the systems I've been involved in, which are coming, which do address that problem. But in the interim, we need common sense solutions, like one, for example, which sounds totally counterintuitive, is to ditch the sour oil in favour of high-grade oil. High-grade oil doesn't contain sulphur, so you don't need lead, you don't need cobalt, which is what's in unleaded fuel. So you don't also need a catalytic converter. In fact, what you do is you ditch a whole bunch of pollutants and greenhouse gases in favour of a fuel which doesn't pollute that and is better for the environment. Common sense. So let's get back to the unleaded fuel. So unleaded fuel uses cobalt, which melts at 1,495 degrees Celsius, so a lot higher than the actual operational temperature you'll find in most engines. I don't think I know of anything aside from aircraft with afterburners, the SR-71 scramjets and pulse ion engines, which have high enough temperatures to melt away the cobalt. So an afterburner will bring the temperature up high enough to melt the cobalt. So I assume that the cobalt is releasing from the sulphur, and there is a reaction occurring with the carbon dioxide emitted from combustion with the cobalt, so with the sulphur forming sulphur dioxide, and the cobalt's just being flung away. But in a normal regular jet engine, the temperatures aren't going to exceed about 1100, 1200 degrees Celsius. So it's not high enough to melt the cobalt, so it's going to remain bonded. In your carburetor, maybe a dragster might get high enough, but I doubt it. A proper iron core engine might get high enough, but modern alloys, no. It's not going to get hot enough because it's going to melt the cylinder block, it's going to melt the engine. So it's not going to get hot enough to allow the cobalt to separate from the sulphur. So we end up with this sulphur and cobalt compound, which is bonded together. That's released into the atmosphere, and it lingers around for about a week to a few weeks in the atmosphere before slowly drifting down and polluting the environment we're in at the moment. The difference between sulphur dioxide and this, sulphur dioxide is reflecting away the sunlight, whereas the cobalt and sulphur is a greenhouse gas. Now, I need you to understand what a greenhouse gas is, because common knowledge is, it's just like a normal greenhouse. Well, a greenhouse allows sunlight in, traps the heat in an insulated container, but the whole purpose, the whole design of a greenhouse is the base, the wood and the walls. These are thermal masses, so sunlight comes in, the heat is radiated, it traps heat in the thermal mass, so as it gets cold overnight, that thermal mass releases the heat, keeps the environment warm. Calling this a greenhouse gas is really the wrong term to use. It's a thermal mass, like asphalt, like concrete. When you understand that, it makes it a little bit easier. So the heat island effect is very similar to what's happening with global warming. Global warming is not the planet's getting warmer, it's localised warming. So when you look at the climate data, you would assume, because it's said to be global warming, it's going to be uniform. But when you look at the data, you might have hot spots, cold spots, and it doesn't make sense. And a lot of people are like, maybe that's that's what its expert says otherwise. It creates this kind of problem with two groups. You have the people that understand enough of the science, which go and say, that's bullshit. That can't be true. Global warming, what the hell's going on here? You've got all these inconsistencies. No, that's junk. I ignore that. And they say, well, it's climate change is wrong. I'm going to ignore that science. It's not real. But you have the others who are very sure they understand the science because they've been either lied to or got people scaring them. It's really bad. You're going to extinction. We're going to die off. You can't ignore this. This is really bad. And they just accept that must be real. The problem is, global warming is a localised warming. So when you look at the data, you'll see high spots, you'll see low spots. It's like the ocean. You go swim in the ocean, you'll find there's hot spots and cold spots, and it's like that. But it's also how the gases are being released into the environment. You'll find it behaves like ebbs and flows and like a liquid up to about 9 stories. So on a really polluted day, you get the gases go up to about 9 stories and then slowly dissipate towards the ocean as it's filtered out by trees, plants and so on, eventually to the ocean, where again the plant life in the ocean starts absorbing, the ocean starts absorbing until we either get it pulled away through the poles or it just gets absorbed by nature. The problem is it's not a uniform temperature, it's sort of an ebbs and flows process, which is why you get very polluted environments and you get clean air environments quite literally a street apart in London. I've come across this walking from St Pancras station to central London. There's a pub I went to, I can't remember where it is. It's near you. So literally just walk from King's Cross station, past that sort of fancy roundish building towards Euston, and you'll go through one street is one of the worst polluted streets in the country, and all the other streets are not that bad. And it's crazy. You can walk across and it's like, oh my god, I'm choking. You go past here. What the hell's going on here? You have this near the Japan Gardens in Shepherd's Bush. You've got one of the worst polluted roads, and when you go into side roads, it's all normal again. It doesn't make any sense until you understand it's like an ocean, it's like a sea. You've got high concentrations of pollution, low concentrations of pollution. The problem with cobalt is we've known from the 1940s it causes asthma, and it's totally forgotten by the 1960s and 70s. We've totally forgotten about asthma being that problem. I looked back at this into war data and what was going on after the war, even through to the 1950s when we had the smogs in London, which was still using unleaded fuel at that point in time. And we're not seeing the connection between the fogs we had over Christmas time and what was happening in London with London smog. It's the same stuff, it's the same product, and we're getting sick. Now, I don't want to go any more on this. I need to explain about the dark skies, but I need you to understand about global dimming and the sulphur dioxide basically reflecting sunlight, and I need you to understand about the cobalt and sulphur, which is a greenhouse gas. It's the same as methane. It's 30 times the heat absorption of carbon dioxide, and I need you to remember that because it's really important. You do. Now, we have an effect called global cooling, which is a result of water dilution of ocean water. So we have the icebergs, ice sheet, the glaciers melting, adding that fresh water to the ocean. A lot of climate scientists happily will talk about sea level rises, and they know everything about it, but totally reject the notion of global cooling because they likely don't understand it. I've seen a number of people, including marine biologists, talking about it. No question, they understand the subject, they're experts in that field, and then they totally miss the point about global cooling. So global cooling is rubbish, it's a conspiracy theory. These are facts, that's a conspiracy theory. But it's exactly the same process. You're diluting the ocean water, you're causing the deep ocean current to slow down, which is also known as the AMOC system, and they're recognising all that and then just totally take off on a tangent, not realising that the reason why the ocean temperature in the Pacific and Indian Oceans getting hot, about over now in places over 20 degrees Celsius, which is killing off the plankton. They attribute to global warming, but that's not being caused by global warming. It's been caused by global cooling. So if you know water toxicity, as a did I remember correctly, your doctor or your nurse? I think you're a professional nurse. I believe you know water toxicity. I had water toxicity during COVID, so I kind of a little bit more familiar on how you can fuck up on that. So what we have with global cooling is basically we're diluting the ocean water, the salt level in the ocean water, and that's causing the AMOC to slow down. As it's slowing down, the circulatory system for the planet is slowing down, so the sunlight concentrated in the Pacific and Indian Ocean is getting hotter and hotter, which is evaporating more and more, causing more and more storms. But as it's evaporating, it's retaining more and more heat, which requires a lot of energy to heat up water. One of the top conspiracy arguments that people put for climate change is, oh, clouds are greenhouse gases. They're not. They are much more like a duvet. They take a lot of energy to become a greenhouse gas because, yes, they're a thermal mass, but they're a very lousy thermal mass. Whereas things like asphalt, concrete, carbon dioxide, cobalt and sulphur, these are really, really good at retaining heat, whereas clouds are pretty lousy at it. So what happens with the cloud is sunlight comes down, it's sort of reflected off by the surface, but also there's the heat which is reflected back down to the surface. So heat coming up, hits the clouds, comes back down, which is why tonight it's going to be freezing cold, because it's already got cold right now. But if it was cloud cover, we've had a hot day, it'd still be nice and warm outside, but as we've had a nice hot 20 degrees Celsius temperature today and got clear sky, it's going to be cold tonight. It's going to be quite nice because it's not going to be hot. But simple science. If you understand it, you understand old wives' tales and old farmers' almanacs. A lot of this is really common sense. So we've got a high altitude cloud up there. We've got screen burn in my eye because I'm looking at the screen and I've got this outline. So that's not a cloud I'm looking at, that's a screen burn. But a lot of it is common sense. Getting back to the global cooling, the other source of dilution to the ocean water is groundwater. We've been extracting lots and lots of groundwater from aquifers, and that's also ending up in the ocean. So what I found last week was wow, it feels like last week. Literally 2 days or 3 days ago, was the tipping point for global cooling, which is commonly believed by those who actually understand global cooling, was 2015-2016. Turns out it's 2011 to 2012. I was looking at a guy called I've forgotten his name. No, I can't. He's the top. He's one of he denies that global warming is real. He's also the presidential-elect advisor on climate change. Interesting guy. He's not wrong, but he's also wrong about climate change. He makes the assertion that global warming is not real, and makes the assertion with the document put out that here's evidence that global warming has stopped, it doesn't exist. Global warming is still happening. The difference is we're seeing global cooling at the moment, and that's the bit I need to talk to you about now. Global cooling has happened since so we have a tipping point in between 2011 and 2012, but the actual majority of cooling occurred in 2019. Now, by 2024, when I last looked at the data, we have the cooling set at 0.9 degrees Fahrenheit or 0.57 degrees Celsius. Now that's directly caused by global warming. Now how I know this is I went into NOAA data, which I'm going to link you the site to have a look yourself. I set aside about 12-14 hours to do this, and that means literally go through every little location, check it from I think I did 2010, because looking back at the past data, there wasn't a trend of global cooling anywhere below 2010. So I picked, I think, it might have been 2009, but I think I picked 2010 specifically because I didn't want to add more and more hours to my day to search through data, which is genuinely boring as hell. So what I would be doing is open up this page, have multiple of these images up and go, check this one, what's the figure, check this one, what's the figure, check this one, what's the figure, check this one, and then cool, I've got the data and I know the trend for that specific location. Then do the next one, then do the next. I think about 500 or something on the page. You have to go through, work it out, and work out where in the US it is, which of the 4 temperature bands it is, because as a planet we have a global average temperatures which are in banded areas. So as you go across the United States, say for Alaska, you have 2 temperature bands, one which is more up in the extreme, but if you go towards Anchorage, so you go up to, I can't think what it's called. It's the place which is the most northern part of the United States. You go there and you've got one temperature band around that area. You go towards Anchorage and there's a totally different temperature biome. So you'll find this area is actually a lot more warmer than up here because the amount of sunlight that gets to that area is less than this area. So you get a bit more sun, so you get a little bit more heat. You go down to the lower 48, you have 4 bandings of temperature. So you got north and south. Am I right? Remember this right? I have problems with internal monologue, so I might go off tangent. Okay, that's the United States. Yes. So North and South Dakota is in one band. Then you have Wyoming. Is that Wyoming? I hope so. New Mexico and no, New Mexico's the wrong area. What's that place called? Oh gosh, I can't think what it's called. I can't remember. But you'll find as you look across the US, there's essentially 4 bandings of temperature down from quite cold to quite warm. And if you look at those averages, you can take a graph, work out what basically the temperature range is, and by 2014 we've noticed we've got cooling of 0.9 degrees Fahrenheit, 0.57 degrees Celsius across the whole of each of those little single locations. So on average the temperature's gone up by bit over 0.9 degrees Fahrenheit, bit up, bit down, but it's on average it works out 0.9 degrees Fahrenheit across the United States in all those metrics, and 0.57 degrees Celsius across all those metrics for 2024. When we look at the solar radiation modification data, they claim that their process has created that amount of cooling. Whereas if you look in this older data, you can start working out where the cold is, how much it's accelerating by, and you can work out basically that this cooling has no relation whatsoever to the Solar Radiation Modification Act. It's purely to do with global cooling. So the planet is getting colder, but it's not a result of global warming going away. It's a result of global cooling having a negative effect on our environment. So it's actually reducing the temperature, making the environment much colder. The problem with the systems being used to darken the skies, number one, you have a massive greenhouse gas being emitted by jets now, which is the unleaded fuel. So you have to get rid of that. The easiest solution is to use leaded fuel again. There go, you don't need to use the Solar Radiation Modification Act because you're actually producing sulphur dioxide, which is reflecting away the sun's energy, and you're creating the cooling which has been in place from, we've got 50 years of data on how it's affected the pan evaporation rates. So if you go to a weather station, you're looking for a pan which is filled with a measured amount of water, how much evaporates, it's topped up, and that amount of top up is measured, and that indicates our pan evaporation rate. So we've got data showing basically how much of the sun's energy has hit the earth, and we can calculate basically how it's affected. We also know how it's affected our environment, where we've had lead pollution, where we've had environmental pollution as a result of jet traffic. We also know from acid rain effects. So when it's just sulphur dioxide in the environment, the effects of acid rain are greatly reduced. The problem is with the Solar Radiation Modification Act, one of the companies, and I will try and find the company's details, uses basically sulphur dioxide powder. So this is the granules of sulphur dioxide powderized, and drops. It's about, I think it's something like a pound or a kilo of the stuff is dropped from a helium balloon. They now say it's hydrogen balloon. Great. The problem is dropping it. You're basically dropping a massive powder down. Yes, it disperses. It goes over quite a big area. When it hits the clouds, rather than being a very fine sulphur dioxide, which sits much higher above the cloud layer and lingers in the air before slowly dissipating down, so the acid rain which is produced from the sulphur dioxide is a very, very, very weak version of it. By dropping the powder, you're basically creating concentrated sulphuric acid. And when you look at the data for where they dropped these balloons, packets of sulphur dioxide, you also notice there's peaks of where we've got acid rain, where people found they've got crops damaged, wildlife, nature being damaged from acid rain. People attributing that to acid rain, so acid rain hasn't gone away, instead it's got worse. And that's, you can trace to that method. So by basically dropping the sulphur dioxide from high in the, I think it's high in the stratosphere. So this is stratosphere is above 30,000 feet up to, I can't remember. Actually, I've forgotten. So yeah, we've got the troposphere is between ground level and 30,000 feet, and stratosphere is above 30,000 feet. To I think it's 60 miles, something in that region. I forget the 1,000 feet. 100,000 feet? No, that won't be it. That's only 5. I genuinely can't remember. But you basically dropping at higher altitude into the atmosphere. Yes, it goes over a massive area. The problem is it's a powder, so it's not going to be a fine. It's not a fine gas. It's a powder which still has clumps together. So when it hits the clouds, it's going to mix with the moisture water vapor to produce sulphur dioxide, and you just have acid rain pouring down, which isn't a solution. The other ones are barium and aluminium glitter. We saw the evidence of what that does in the forest, in the fires in Los Angeles. We've seen it in multiple other fires, which is an accelerant. Now there is now a beryllium oxide and aluminium, which is an incendiary. And if you take away the oxygen, so you just have beryllium and aluminium as a glitter, is an accelerant when you apply microwave energy, or if you can find some sort of high ignition source. And it goes into conspiracy theories, but I don't believe Mossad created those walkie-talkie and pager explosives which attacked Hamas. China's been bragging about their technology for a while, including having ways of taking out things like with solar panels, smart meters and stuff like that, having batteries which explode. It's not a stretch to see that's probably more likely where that came from. And it's not a stretch to be concerned when we're talking about building, well, we're seeing a nuclear power station which has rust on it, rust which shouldn't be there because the types of materials being used to manufacture that steel for the containment vessels doesn't rust, and yet it's rusting in the nuclear power station, means it's not the right stuff. It's a problem. And when we're seeing shortcuts being done and facades by China, that's concerning. But as far as what the problem right now is, that Solar Radiation Modification Act is basing its science on global cooling. And because it's basing it on global cooling, and we're making assertions based on global cooling, we're literally being told this is going to stop global warming. It's a guarantee. It's going to do fuck all. All it's done for the Solar Radiation Modification Act on NOAA's own data shows a trend where it's done nothing during testing except create acid rain. it's done nothing but helped perpetuate forest fires, and it's polluted the environment. What good is that? Well, we still have unleaded fuel, which is polluting the environment because it's a greenhouse gas, and it's one which causes asthma respiratory problems through the 1940s and 1950s. We forgot about it by the 70s. We have smog, which is being caused by the same process from unleaded fuel, which again we forget about. And it's kind of crazy. We have these stupid notions. This will solve the problem. Trust us. It's not. Anyway, so it's got very dark now. I'm going to go indoors. I'll be writing the letters as soon as I can and try and get that off to you tonight. But no, that's the context I think is important to know. And I've tried my best. I've done as much as I can over the years because I've been a climate scientist since '93. Prior to that, I was doing lots and lots of recycling as an environmentalist. I worked with the Crawley Fifth Club Scouts, and we collected newspapers. We a lovely guy called Colin Curtis. He's a guy that co-designed the Route Master bus. He's also quite an avid environmentalist. He cared about the environment, cared about recycling, and understood the importance of it. And we're in the situation now. We're seeing the planet get worse, and genuinely, they sound like idiotic solutions, but quite literally, if we ditch sour oil in favour of high-grade oil. High-grade oil is the stuff you make plastics on, food-safe plastics. Medications should be made from high-grade oil rather than sour oil, because again, you've got sulphur contamination, and if it's post-production, you have cobalt contamination, you have sulphur contamination. So we should be making the fuel oil be high-grade oil. Now, currently, you can go and buy that for your high-performance car. It costs about 5 times the price because it's produced in small amount of quantities, and it's basically designed to run the engine as high efficiency as possible. If you were to use it in a normal car, because it's not unleaded, well, it's not going to be a problem. It just runs it normally. The biggest the biggest take from this is by using high-grade oil, you end up basically with no need for lead, no need for sulphur. No need for lead, no need for cobalt, and more importantly, no catalytic converter. And if you know what catalytic converter does, it basically turns waste fuel, waste fuel and ozone into methane and water. So basically, a tool which is designed to help fix the ozone layer gets rid of ozone and produces methane. So it pollutes the environment whilst also not fixing the ozone layer. It's a pretty dumb move. Whereas we can switch to high-grade oil, which is what I'm pretty confident the Trump administration are actually doing at the moment, which is the Gulf of America is one of the areas in the United States which has high-grade oil. It's in plentiful supply. Assuming that's why they're mining there. You also have it's not Prudhoe Bay, it's north of Anchorage. You have one of the larger oil fields in Alaska, which again I think is a high-grade oil, but I might be wrong on that one. I'm pretty confident I'm wrong on that. But down where we have the Gulf of America, you have high-grade oil in surplus. So by tapping that, they can actually turn the cars and vehicles and trucks, planes and boats from being heavily polluting to actually pretty green. It's not the perfect solution. Perfect solution's coming, but that takes time. And the problem is scalability. But this darkening skies, that's a crazy idea. It's not scientific. I've explained this through to my local MP, which is Peter Lamb, for Crawley. I've written a couple of correspondences to the Prime Minister's office, but I don't hear anything back. So I go see him, they're just, he doesn't know anything and ignore it. So I thought I need to let you have the extra bit context. I'm sorry this has run on for 15 minutes. Thank you very much for your time, sir. Take care now. Bye. Thank you for doing a wonderful job.